Hello and welcome to another deep dive. So this time around we're going to be taking a look at an area called reflection. So we're not talking about reflection from a graphics point of view where we'd be looking at sort of mirrors or reflective surfaces. We're talking about reflection in terms of a coding technique. And it's a coding technique, a system that we've got access to that allows us to actually procedurally work with other code. And so it lets us do some really cool tricks. We can discover other areas of code and we can locate variables and functions and interact with them, regardless of whether those are public or private. So it can be really, really powerful for some systems. It's something we do need to be cautious with using. You don't want to just go absolutely full on and putting reflection in everywhere because there are obviously performance costs. It's also stuff that can add complexity and difficulties with working on some platforms, in particular mobile platforms. So we want to be a little bit cautious with where we're using it. I tend to mostly use it in editor-based things. But let's dive on in and see the kinds of things we can actually do with it. So what I've set up to start off with, we've got a reflection demo and a reflection target script. And so we're going to start really simple with we've got an existing thing and we want to discover the particular things that it has within it. So let's take a look at our code. So our reflection target, I'm going to create a couple of things in our reflection target. One of the things is I'm going to create a private function and test private function. And we'll just be able to log out that it ran. Because what we want to be able to do is normally this, I would not be able to call it from reflection demo. I would not have access to it. But through using the reflection tools, I actually will be able to access that. So what I can do is if I go using system.reflection, then immediately then is going to give me access to a bunch of different things. So what I can generally do is, so my reflection target, I want to get the type of that. So type of reflection target, and then we'll have access to a bunch of different things. So one of the things there is we have access to get methods. So get methods allows us to search for different methods. So we can put in particular things called binding flags. Binding flags allow us to filter the particular things, or we can just retrieve all of the particular methods. So let's see what we get with that. All methods equal to, and let's just debug log those methods. Method in all methods. And then what we'll log out is debug.log method, and we'll likely have a name parameter we can use. So let's run this and just see what information we can start to get out from this. And in particular, we want to see if we see that private function. We've got multiple private functions there. So we can see, well, we've got get type to string. We can see the functions for the name properties, so the getter and setter. Can see a whole bunch of ones in here. Send and broadcast message that we've potentially seen before, compare tags. So this is getting all of the methods that that function has, which is going to include ones from the parent classes. So we can see we have a lot of different ones that come through, all of the coroutine ones, lots and lots and lots of different ones. Doesn't look like we can see our private method in there. Now it's not sorting these by name, but what we can do is we can actually change this get methods. We can provide some binding flags because the default binding flags are not actually going to find typically private methods. We would need to specifically say non-public. And there are other binding flags that we've got access to as well. So if we wanted public and non-public ones, then we could say that. We also have ones where we can find specifically things that are static functions. So really handy for being able to find particular ones. So if I chuck in non-public, and then let's see what we receive back. So binding flags let you do some high-level sort of filtering there. So with that, we're not getting anything back. So we can tweak our binding flags here. We've got a few different ones, so instance and static as well. So instance is kind of the counterpart to static. So we could say that, well, we're wanting to know instance ones as well. So let's see what that gives us back. We often need to use a combination of binding flags to retrieve all of the particular ones that we're after. If we run that, we can see that is managing to find some particular ones. So we can see test private function, start, update, our familiar functions all appear there. So, okay, that's pretty good. Let's, that'll grab us all the methods. Let's try and retrieve that particular method. So we can again type of reflection target get method. And in this case, we know what that method is called. We know it's called test private function. So we want to retrieve the one that is called test private function. And again, we can provide the binding attributes. So in this case, we're specifically wanting something that is non-public and an instance. And then we can store that. So found method. And then with that, we want to run it if we retrieved it. So f found method is not equal to null. Then found method, and then we can invoke this. Now the way we invoke these is really quite interesting. So we notice we've got a couple of different ways of invoking it, but the key thing is the first parameter when we're invoking it is because what we've been doing here is all based on the type. We haven't actually said what function, what object you're running this function on. So we have to tell it. We have to say, okay, well, I want you to run on this target. Now, it would be different if it was a static function. We wouldn't need to do that. We could provide null. Now, we also need to pass in if there's parameters. So in this case, null. And I'm also just going to put result here. And I want to debug log the result from that. So let's see, does this run it correctly? What do we get back as the output there from that invoking of it? So we'll let this run. And it ran. We got null. Let's change our test function here so it returns a string. And then let's see what we get back. Do we still get back null? Do we get our string back? Do we get something in between where we get something back and we need to convert it to our string? Let's take a look and see what we actually get. So in this case, we got back the return value. So with reflection, we can locate a function, we can invoke it, we can get data back. Well, let's make it that we can pass a parameter into this. So string person's name, and we'll return back person's name. So we need to pass an input into this now. So those inputs we saw, it has to be new object. So object with a lowercase o is the root variable type for any variable in C#. So everything can be cast to an object. So in this case, I'm going to use my own name. And let's run that. Let's see if that's correctly passing parameters in, if it's then working with those and giving us back output. So we'll see in a moment. So that's run. It's given us the correct output. So that's working the way that we're after, which is great. So with that, okay, that's pretty cool. In this case, we knew the exact function. What if we didn't know the exact function? What if we needed to, traverse through different classes and actually find a particular function? So we can do a little bit more in terms of, with this stuff, because found method, if we take a look and see what extra information we've got, one of the things we can access is attributes. And this is where things can start to get really powerful, where what I can do is I'm going to create a specific attribute here. It's just going to be a really, really simple one. So public, let's call this marked method attribute from system attribute. And then with that, we need to do system attribute usage. So attribute targets, we want this to only be, by default, it's going to be typically on a lot of things. We only want this to be valid on a method though. So it's only usable on a method, because then I'm going to have a method here, int method to find, and this is just going to return random range from 1 to 7, and then marked method. So I want to only find the methods in this class that have that attribute on them. So a couple of ways I can approach this. We already know we've got the method for finding all of our particular ones. So we can go back to having this set up. So I'm going to bring this in. Now we still want non-public and instance. I'm actually going to add in, because we've got that attribute, binding flags public, so we can have either one. The key thing is it's going to be an instance function. Then for each the method in all methods. So we want to check if this method has that attribute then. So method.attributes, so that contains a lot of different particular ones. So let's take a look and see what we actually get for this. So I want to debug log out method.attributes, just so we can see what we actually are finding with that. So I'm going to put the method's name in first. So method name, and then the attributes, I'll put on another debug line after that. Debug log, method attributes. Just so we can see what we're actually getting out there, of if we're finding any attributes, what those attributes might be. This will just help to sort of filter looking at what that particular data looks like. Because this is the thing, sometimes we get good documentation with things, other times we don't always get great documentation with stuff. So we can see start, so that has a couple of attributes. We can see method to find, so that looks like it has some things there, but we probably need to dig a little bit more into the particular bits of data that it's got there, because we can actually search and see, okay, what particular attributes are on it. So that's something that when we're doing that, we want to actually particularly check and see if it's got the specific attribute that we are looking for, which we can actually do that. So we can actually go and check and find, does it have this particular one? Because what we can do is, so method, if we have a look at all of the attribute ones, you can see it has a get custom attribute. So we can see, okay, well, let's try and do get custom attribute for our marked method attribute. var found attribute. So if it didn't find it, so found attribute equal to null, and we just continue. Otherwise, we're going to log out that method. So we'll just try and retrieve that particular custom attribute, and we'll see how well that works. Because this should ideally mean that we just get one debug output that is just saying, yep, here's the particular one, which we did. That means I could actually have multiple things in here. So let's have other method to find. It's also a marked method. So I'm going to debug log the name, and then I'm going to invoke it. And I'll display the output there for it. So I would do method invoke target and null. So now what we should be seeing happening is it's going to run each of those methods, it'll get the output from them, and it will display it alongside their name. So we can see it's working. So this allows us to have information that's private, but through using attributes, we can mark it as something that can easily be accessed and found, which is really powerful. So really handy for being able to do stuff like that. Now in this case, we know the class. What if we don't? What if we don't know the class and we want to find a particular class that has that actual method in it? So for example, let's say we set up a new file which will keep this set up large. Actually, I can put it in this particular one. We're going to set up a class, public class to search for, and this is going to have public static int function to run. And this is going to do similar to the other ones, random.range 1, but in this case to 13. So I'm going to make this a marked method. So this, I want to now try and find this. And I want to try and find this with the only thing I know is that I'm looking for something that has a marked method on it and that returns an int and takes no parameters. So now it gets trickier because I need to locate the type first, because all of these other ones I already had the type and I was able to loop over that. In this case, I don't. So firstly, I have to actually find the types. So we have access to this thing called assembly, and we can access our calling assembly. So get calling assembly or get executing assembly. So let's take a look and see what we get for those. What do we get as the output for those in terms of, do we get anything different? Is it exactly the same? So objects in C# are grouped into assemblies, and potentially we could be running in one assembly and we could try and access stuff in another assembly. That's something that we actually do all the time. Anytime we're doing a using, that's typically bringing in another assembly. And so we can easily be crossing over different assemblies quite easily. So we can see we are running in the same one, so the calling and executing one is the same in this case, which it corresponds to our particular project. So that's great. So current assembly equals assembly get calling assembly. Now we need to find the classes within that. So current assembly, we can access information within it. It has types. So we can fully go through and loop over all of our types. So for each var candidate type in current assembly get types. Now this candidate type could be a lot of different things. This could be something that is an enum. It could be a struct. It could be a whole manner of different things. So we can filter this. So f candidate type, and there's typically a lot of these is functions. So specifically, is it a class? And if it's not, we're going to skip it. It's not a class, we're not interested in it because it can't possibly contain the information that we're looking for. So it's not a class, so we've skipped over that. Now we could retrieve the methods. So var class methods equals, and then we can ask that candidate type get methods, and we know that we need to find things that are non-public or public, and in this case, well, actually, we know we're kind of looking specifically for a public thing, so we can make it that it has to be public, but it's not instance, it's static. That's going to filter down the amount of data we're actually processing through, because then we can check through candidate methods, candidate method, and class methods. And similar to what we were doing here, we can check, has it got that attribute? And I can largely use this exact code from here because it's going to do pretty much everything that we're after. So we've got our candidate method. Now the big difference is when we invoke that with null. And it would be nice to include the class in this as well. So let's make sure we put in candidate type. And we've got a lot of different names that we can actually be using here for this. But let's just put the basic name in there. So that should, we're traversing all the classes, all types in our assembly. We're skipping if it's not a class. Then we're traversing all methods. And then we are attempting to retrieve our attribute, because the presence of that attribute indicates what we're looking for. So let's test with that. We've got a static class there. We've got a few bits hooked up. Is this going to correctly find it and run it? So it runs, and class name, function name, and it's given us the output. We could do further where we could actually provide an attribute that has to be on the class. That would allow us to do some earlier filtering, and that attribute on the class could specifically indicate, well, here's the function to run. So run this function, and then you can actually filter here. What it's doing is, rather than just searching through all the methods, it says, oh, okay, you've told me this is the method to look for. Let's use that, try and retrieve that specific one. So we could set up public class, marked class attribute, and that's going to be a system.attribute, and this, we're going to make it that the attribute usage is specifically, it can only be applied to a class. And we're also going to make this so it can store a little bit of information. So we're going to give it target function, which will be a string, and we'll make it that we have to supply that for setting it up. So marked class attribute, string, target function. We just store that. Target function is equal to our target one. Because what we can then do is in this, okay, marked class, we have to provide the target function to run to. So in this case, it's not going to be a marked method. It's just going to be a specific one that we have to name here, which we could name multiple ones. So, okay, what we're going to do for that is, well, this is our logic for running over all the methods. That's completely fine. Check if this is a marked class. Because we can say, okay, well, candidate type, get custom attribute, marked class attribute, class attribute. If it is, so if class attribute is not equal to null, then, well, class attribute has target function in it, which means we can go and say, hey, candidate type, get method, and we can give it the specific one, because we know class attribute, target function. We can apply our binding flags again as before. And what we would then do is found method, and we'll check that we did find it. So found method is not equal to null. Then we will be able to run it. So we can do a similar setup that we did here, where we're logging out the results of doing that. So in this case, candidate type is the same, but this becomes found method, and we invoke the found method. So that should mean that when we run this, it will actually run function to run 2. So let's test it. Because this can be really handy, and you'll see some cases where Unity uses it for custom setting. Okay, yep, this is the function to run in a particular use case. And that's how Unity's, those attributes are actually working. So we can see function to run 2, and we can see, yep, found it in 2 search for, and it was function to run 2. We could modify it, have it run the other function if we wanted to. The key thing is this gives us just a way of being able to set up some really powerful things. So in terms of how and where you would want to use this, stuff that's primarily going to be in the editor is often a good candidate for this. I generally recommend a lot of caution with using it at runtime, in particular in sort of final builds, just because it does often have more overhead. Cases of where I've used it a lot have been things like making a developer console, because with that, I don't want to have to manually link up all of the potential commands. I want it to be easy for people to add in new commands. So that developer console uses reflection to be able to actually do that. So it uses reflection to discover what the classes are. That also means I can have generic functions in there of, okay, set a vector3, set a boolean, set an integer, and they can work on classes that never even existed at the point in time where the developer console was created, and can work for things that it just dynamically discovers, which is really powerful. And so great for things like if that Unity uses reflection and processes like that for being able to find various functions and run them. So really, really handy, useful tool there. But generally, as I said, I would recommend keeping it to stuff that's more primarily editor side, and also keep in mind that performance overhead there. But certainly for things like developer console, stuff like with that, super powerful. It can allow you to write code that's a little bit more generic, that can be discovering and interacting with the code, and can use that to actually give you really powerful results and allow you to actually save writing a lot of code, and allow you to, in particular, decouple a system from the things that it's interacting with, which again can also be really good. It allows you to work on those in isolation, and that tends to help out a lot with developer processes there. Lets people work in parallel a lot more. So dive in and experiment with this stuff. If you want to grab the code for this, the full code for it, as always, is up on GitHub. I've also, my developer console is something that's freely available, so if you want to check that out, then take a look. That's doing a lot of stuff combining reflection and also link. The other thing that I'll put a link in the description to is my template Unity project, and it uses reflection for being able to actually generate UI. Now that generation happens at editor time, so it's done in the editor, it's an active thing that the user does, but it creates the settings menus there, and it actually also generates code. So it uses reflection for finding and generating stuff to then generate more code. So grab all of those, take a look, experiment with it, see the kinds of things that you can be creating with it. And there's a lot of cool things you can do there. If you have found this video helpful, please do chuck in a like and subscribe. It is something that really does help out, very much appreciated. If you're looking for other ways to support the channel, I do have a Patreon, and the link to that's in the description below. And as always, if you've got questions, do chuck in a comment. If there's cool things that you've done using the code, chuck in a link as well. I'd love to hear about cool things people have done with the stuff. Bye.